Have you ever wondered if a function can be the same as its inverse? Well, guys, you're in for a treat. Now, if you're unsure about what an inverse function is, be sure to check out this other video, and I have a link to it in the description below as well. But for this video, let's focus specifically on a special class of inverse functions called self-inverse functions. When we talk about the inverse of a function, we're basically looking for its alter ego. So when we're trying to answer whether self-inverse functions even exist, let's approach the graph and see what it looks like when we take the inverse of a function. So on a graph, what does the inverse even look like? Well, a key takeaway is that a function's inverse is going to look like a reflection over the line y equals x. Now I want you to imagine this line acting like a mirror. Can you think of any functions where they would have symmetry over this line when finding the inverse? Now, what I mean is, do they basically have a mirror image reflection over this line? Take a minute and pause the video and see if you can think of one. Okay, so you'll notice that at the top of this video, I gave you some example functions here. Now, some of these may or may not have inverses, but I want to look at one in particular for our deep dive into answering the question about whether special inverse functions even exist. Let's focus on 1 over x. So when we're talking about 1 over x, let's go ahead and graph this. This is known as a hyperbolic function, and I even drew y equals x as a line on the graph for reference again. Now you'll notice something really interesting when you look at the graph. Notice how it looks like there's symmetry on both sides of the line y equals x. You might be convinced now that, okay, well, could this be a function that has an inverse that happens to also be 1 over x? Let's actually dive into the math behind whether that's in fact the case or not. But before I get into it, if you haven't already, hit that subscribe button and leave a comment. Tell me what you think of this video and any other video tutorials you'd like to see. So if we want to be certain when answering this question, let's dive into this mathematically. We're going to write the original equation y equals 1 over x here. And we want to solve this equation after swapping the variables x and y. We're basically swapping the domain and range when trying to find the inverse function. So after swapping the variables x and y for the original hyperbolic function, we're going to be left with x equals 1 over y. Now you're going to simply want to solve for and isolate the variable y. So we'll multiply y by both sides, getting xy equals 1. And then finally, you'll notice that when you divide both sides by x, the result happens to be the exact same function we started with. So we can definitely say that yes, self-inverse functions do exist, and the hyperbolic function 1 over x is an example of this. And here's a fun homework question for you. Can you think of any others that follow this principle? Drop a comment in the section below and let's see what you come up with. And I just want to thank you guys again for checking out my video. And if you haven't already, check out this other playlist that you see on your screen. I'll catch you later.